All right, today we're going to talk about solving inequalities and the difference between an equation and an inequality. So, an equation and an inequality can be denoted with an equal sign versus an inequality sign. You could have a less than, a greater than, a less than or equal to, or greater than or equal to with an inequality. In an equation, you're going to be solving for a set number of solutions, and in an inequality you're going to get a range of solutions that will satisfy. So the goal is to get the variable by itself, just like solving equations, and then remember to switch the inequality if you are dividing or multiplying by a negative number when solving. Then you're going to graph the solution on a number line if asked. If it's a less than or a greater than, you will have an open circle, and because it can't actually be that value that you're going to graph. And then if it's a less than or equal to or a greater than or equal to, you're actually going to put a solid point because it can be equal to that number. Okay, so let's try one together. The first one we have is x minus 1 is less than 2/3 times 6x minus 9. So first thing I'm going to do is remember that I'm just going to treat this mainly like it is an equal sign and just solve. So I'm going to distribute the 2/3 to both of those. So I've got x minus 1 is less than, when you're multiplying, when you have like 2/3 and 6 is technically 6 divided by 1. So you're multiplying the numerators and you're multiplying the denominators, just as a reminder. So 2 times 6 is 12. Divide that by 3, you get 4. So 4x. Then 2 times negative 9 would be negative 18. Divided by 3 would be negative 6. Then from there, I like to subtract the x to the side where it's going to be positive, but honestly, it doesn't matter either way. So that gets rid of my x there. And then I'm going to add a 6 to this side, which gives me a 5. And then I haven't divided it by anything yet. So right here, I'm going to divide by this 3 in order to get x by itself. When I look at this, I want to make sure it's not negative. It's not, so I don't have to switch the sign. So I have x is greater than 5/3. Now, on a number line, 5/3 is going to fall somewhere between 1 and 2. It's greater than 1 because 3/3 would be 1. Okay, so 3 divided by 3 would be 1. This is 5/3, and then 2 would be 6 divided by 3. So it's going to be a little bit closer to the 2. I know that it is going to be graphed as an open circle because of the less than sign, or the sign right here doesn't have an equal to, and it's saying that x is greater than the 5/3. So what that means is I'm going to draw a line going this way, that any value greater than 5/3 would satisfy the situation. All right, let's try another. So this time, we have 5x minus 3 is greater than or equal to 4x plus 2. So I'm going to rewrite that down here. 5x minus 3 greater than or equal to 4x plus 2. So let's say I wanted to subtract the 5x from both sides because I'm trying to get x by itself. So that would leave me with negative 3 is greater than or equal to negative x plus 2. I'm going to go ahead and subtract the 2. So it'd give me negative 5 is greater than or equal to negative x. Now I need to divide by negative 1 to get the x by itself. At this point, I need to make sure I remember that I divided by a negative, so I am going to have to switch the sign. So I'm switching the sign in the next step, and I have x and a positive 5. So x is going to be greater than or equal to 5. So in that case, I'm going to go ahead and graph the point at 5, and then greater than or equal to is going to be above. Now, if that had said less than, then I would have just drawn it going to the left instead of to the right. So in solving inequalities, we're going to get the variable by itself, just like solving equations. We're going to remember to switch the inequality for dividing or multiplying by a negative number, And then on the graph, we're going to make sure that if we have a less than or a greater than, it's going to be graphed as an open circle. And then if it's a less than or equal to or greater than or equal to, it's going to be a solid point. So that's solving inequalities.